Hello guys, my name is Ray. Today we're embarking on an adventure, one that takes us into the heart of the universe's most compelling phenomena, black holes. Now I know what you're thinking. Black holes, aren't they those cosmic vacuum cleaners sucking up everything in their path? Yes, they are, but they're also so much more. Imagine a cosmic beast with an insatiable appetite, gobbling up stars, gas, dust, and even light itself. Sounds like my cousin at a buffet, right? But don't worry, unlike my cousin, black holes aren't coming for your lunch, or are they? Just kidding, they're light years away from your sandwich. Whether they intrigue you or terrify you, there's no denying that black holes are fascinating, so buckle up and prepare for a journey into the unknown. Now let's dive into the mystery of these cosmic giants. So you might be wondering, what exactly is a black hole? Well, let's dive right into it, shall we? Picture this. You're at a party, and there's this person in the room that everyone is drawn to. They're not the loudest or the most flamboyant, but there's just something about them that pulls you in. That's a black hole in a nutshell, only with a lot more gravity and a lot less charm. A black hole is a region in space where gravity is so strong that nothing can escape its pull. Not your spaceship, not intergalactic dust, and not even light. Yes, you heard that right? Light, the fastest thing in the universe, can't outrun a black hole. Now that's some serious gravitational pull. You might be thinking, how does a black hole get so powerful? Well, it's all down to mass and space. When a massive star collapses under its own gravity, it squishes all of its mass into a tiny point in space. This point, known as a singularity, is where the magic, or rather the gravity, happens. Around the singularity, there's an invisible boundary called the event horizon. This is the point of no return. Anything that crosses this line is forever lost to the black hole. It's like that one friend's house where stuff goes in but never comes out. You know the one. But don't worry, black holes aren't just roaming the universe, gobbling up everything in sight. They're actually quite rare. And you'd have to be extremely unlucky to stumble upon one. And even if you did, you'd be stretched into a long, thin strand of atoms, a process affectionately known as spaghettification. Now, that's not a way you want your pasta or yourself to end up. So to sum it up, a black hole is a supermassive party pooper with an insatiable appetite and a serious case of gravity. In other words, once you're in, there's no coming back. Kind of like when you enter a fast food joint hungry, right? Not all black holes are created equal. That's right, my friends, there's quite a bit of variety in the black hole community. There are three main types: stellar, intermediate, and supermassive. Let's start with stellar black holes. These are the most common type of black holes originating from the death of massive stars. When a star approximately 25 times the size of our sun exhausts its nuclear fuel, it collapses under its own gravity, creating a supernova explosion. What remains is a core, so dense that nothing can escape its gravitational pull, not even light. Hence, a stellar black hole is born. Next up, we have the intermediate black holes. They're the middle children of the black hole family, often overlooked but still fascinating. They're bigger than stellar black holes but smaller than supermassive ones. These elusive entities are thought to be formed when stellar black holes merge, or possibly from a stellar cluster's core collapse. However, they remain the most mysterious type as they're quite rare, and their formation theories are still being hotly debated by the scientific community. Finally, let's talk about the big daddies of the black hole world, the supermassive black holes. These are the behemoths of the cosmos, with masses that can be millions or even billions of times the mass of our sun. The exact process of their formation is still a mystery, but one theory suggests they may have formed from the accumulation of mass over time, or from the collapse of an incredibly large cloud of gas at the dawn of the universe. These supermassive black holes are often found at the center of galaxies, including our own Milky Way. They play a pivotal role in the formation and evolution of galaxies, making them an intriguing subject for astronomers. So there you have it, folks. From the modestly sized stellar black holes to the elusive intermediates, and all the way up to the gargantuan supermassive black holes, the cosmos is teeming with these fascinating celestial objects. Just like people, black holes come in all shapes and sizes. Guess what? Our own Milky Way has a black hole. Yes, you heard it right. Sitting right at the heart of our galaxy, some 26,000 light-years away, is a supermassive black hole named Sagittarius A*. Now don't let the name fool you. It's not a new star sign, but indeed a cosmic beast. This black hole is a supermassive one, which is a bit of an understatement, considering it's about 4 million times the mass of our sun. That's like putting the entire population of New York City on a scale and then multiplying that weight by over 1 billion. It's a weighty matter indeed. So where exactly is Sagittarius A asterisk chilling? It's lounging at the galactic center of our Milky Way. If you could see radio waves, you would spot it in the constellation Sagittarius, hence the name. But don't worry, despite its monstrous size and mass, it's not close enough to pose any threat to our solar system, so we can still enjoy our morning coffee without any cosmic interruptions. And here's an intriguing fact about Sagittarius A asterisk. It's constantly on a diet. Yes, this black hole is surrounded by an accretion disk, a swirling buffet of gas and dust that it slowly feasts on. As it chows down, the material heats up, releasing a lot of energy, which we can detect as radio waves. So it's essentially a cosmic radio broadcaster, sending out signals from the heart of our galaxy. In fact, it was these radio waves that led to Sagittarius A's discovery back in the 1970s. So even if black holes are known for their stealth, our Milky Way's own has been making its presence known for quite some time. And there you have it. A brief introduction to our local cosmic monster, Sagittarius A asterisk. It's a supermassive black hole with supermassive appetites, sitting right at the center of our galaxy, and yet completely harmless to us. So we're living right next door to a cosmic monster. No big deal, right? Now, let's talk about the biggest black hole in the universe. Its name is Ton 618. And trust me, it's not just your average run-of-the-mill garden variety black hole. Oh no, it's a supermassive black hole. How supermassive, you ask? Well, let me put it this way. If our sun was the size of a golf ball, Ton 618 would be the size of Mount Everest. That's right, it's that colossal. Located in the constellation Canes Venatici, Ton 618 is estimated to have a mass of about 66 billion times that of our sun. Yes, you heard it right, 66 billion suns. It's so massive that it's got its own zip code. Well, not really, but you get the point. This black hole is so gigantic it could swallow our entire solar system and still have room for seconds. Ton 618 is so big it makes our black hole look like a baby. Talk about size envy. Black holes aren't just in science textbooks, they've made their way into pop culture too. And what better way to talk about black holes in popular culture than to dive right into a cinematic masterpiece that's all about them. Interstellar. Interstellar is a sci-fi epic directed by Christopher Nolan that takes us on a journey through a wormhole and into another galaxy. Now you might be thinking, wait a minute, we were talking about black holes, not wormholes. Well, you're right. But here's the thing, the movie's depiction of a black hole, named Gargantua, is one of the most scientifically accurate portrayals of a black hole in film history. The movie's depiction of Gargantua, a supermassive black hole, is not just a random CGI spectacle. It's based on real scientific calculations and theories. Kip Thorne, a theoretical physicist and Nobel laureate, worked closely with the filmmakers to ensure that the portrayal of the black hole was as accurate as possible. The result is a visually stunning and scientifically sound representation of a black hole that's as close as you can get without actually falling into one. What's more, the film doesn't just show us what a black hole looks like. It delves into the effects of a black hole's gravity on time, a concept known as time dilation. In the movie, characters experience time differently depending on their proximity to the black hole, a concept that's straight from Einstein's theory of relativity. So if you've seen Interstellar, you've seen a black hole, well, a Hollywood version of it at least. But remember, it's not just a fancy special effect, it's a representation based on real science. The movie's black hole is as much a character as Matthew McConaughey or Anne Hathaway, playing a pivotal role in the story and serving as a stunning visual representation of one of the universe's most intriguing phenomena. So, next time you watch Interstellar, you'll know a thing or two about the black holes in the story. Well, that's a whirlwind tour of black holes for you. We've darted through the cosmos, unraveling the enigma of black holes, their types, and the supermassive black hole at the heart of our Milky Way. We've even touched on the gargantuan black hole that holds the record for being the largest known in the universe. And let's not forget the cultural impact of black holes with a nod to the cinematic masterpiece, Interstellar. Thanks for joining me on this cosmic journey. Until next time, remember the universe is full of wonders waiting to be discovered.